All right, here are quiz 1 solutions for Math 112. Problem 1, which is kind of the majority of the test here, you're given two different functions and asked to find their inverse function. So kind of implied in here is that these functions are one-to-one. So I don't know, the way I taught you to do this is this 4-step process. The first step being kind of stupid, but whatever. Change f of x into a y. Why? Because you're going to kind of be doing some algebra and it'll help to move y's around as opposed to f of x's around. Second step, this right here is an equation that represents the function, but what you're trying to figure out is an equation that represents the inverse function. So if you remember that what inverse functions do is they switch around the input and the output of the function, then I can represent that in an equation by switching this output right here and these inputs right here. In other words, everywhere you see a y, change it to an x. And everywhere you see an x, change it to a y. And then from here, to finish the problem, you want to solve for y. This specific type of problem is kind of challenging to solve for y. I think we did one of these in class because they're so hard. And it's a challenge because you have multiple y's. There's a y here and there's a y here. And to further complicate things, there's y's in the denominator, which is kind of a mess. So the way I like to do it is first get rid of the denominator. Get all the y's up on the same line. Multiply both sides of the equation by y plus 3. So that leaves me with x times y plus 3 is equal to y. Now we fixed the denominator problem, but we still have the problem of multiple y's. And the way we'll fix that is by factoring, but it won't help to factor until we get all the terms with the y in them on one side of an equation. So in order to move the pieces around, I'm going to get rid of the parentheses. I'm going to take this x and distribute it through. So I got xy plus 3x is equal to y. And now I'm going to get all the terms with the y in them on one side of the equation. So maybe I'll subtract xy over here. So I got 3x is equal to y minus xy. And now I could factor out a y because both of these terms have a y. And if I pull a y out of each of these terms, what's left behind is 1 minus x. So I got that 3x is equal to y times 1 minus x. So I can now isolate the y by just dividing both sides by 1 minus x. I got y is equal to 3x divided by 1 minus x. And technically, to finish up the problem, I should make it f inverse of x is equal to that thing, 3x over 1 minus x, and call that my answer. Maybe FYI. This is the same as negative 3x divided by x minus 1, or negative 3x divided by negative 1 plus x, or I'm sure there's lots of other ways you could write it as well. I only make that comment because I think a lot of people back here would move the y's to the left-hand side of the equation, just they're comfortable having the variable they're solving for over there. And if you did that, you'd end up with one of these two forms. But they're all the same, so I don't care what you do. I'm going to call this my answer. I'm going to move on. Part B here is really the same idea. It's just saying find the inverse. So I'll go through those same steps. I'll first make it y equals 1 minus 2 times the square root of x cubed plus 4. And then I'll switch the x and the y to come up with an equation that represents the inverse function. So 1 minus 2 times the square root of y cubed plus 4. And this might look like a nightmare, but this one's actually a little bit easier than the other one in my humble opinion, because I only have one y that I'm trying to solve for. I don't have to worry about that factoring trick. I just got to isolate this y. Get it all by itself. So, I don't know. I bet most people would subtract 1 from both sides of the equation. I'm going to add this 2 times the square root of y cubed plus 4 to both sides of the equation, and then that'll leave me with 1 minus x. So what I did is I added this to this side and I subtracted x from both sides. And the reason I moved this over here is just to keep more things positive. Well, maybe that's a bad idea because I want my answers to look like what yours will look like. At any rate, here I could divide by 2. So I get the square root of y cubed plus 4 is equal to 1 minus x divided by 2. And now to get rid of this square root, I'm going to square both sides of the equation. 1 minus x over 2 squared. If you feel like expanding this out, you can, but you don't have to. I would then subtract 4 from both sides of the equation. So I got 1 minus x over 2 squared minus 4. And finally, to isolate the y, take the cubed root of both sides of the equation. So for my final answer, I got, well, I guess my final answer should say g inverse of x equals the cubed root of 1 minus x over 2 squared minus 4. Maybe I'll be lazy here and I'll say g inverse of x equals that thing. And that would be my answer. That looks horrible. How about this? G inverse of x equals that. Fine. Call that good? And then finally, I guess this is like a theory question. We talked about being one-to-one a lot. It's really important in the context of inverse functions. So what does it mean? Explain in words what it means for a function to be one-to-one. And then parenthetically I wrote, it might be easier to explain what it means to not be one-to-one. That's kind of the way I defined it. Sure, I'll do that. A function is not one-to-one if there are two or more inputs that yield, that correspond with the same output. Output, spelling is hard. There you go. I think that would be the easiest way to state what it means for a function to be one-to-one, is kind of define it negatively. This is what it means to not be. If you're not this, you're one-to-one. Should I explain what it... I guess I can give a definition of one-to-one, or a function is one-to-one if every input yields a different output. Maybe I'll just write or similar, because I'm sure everyone's going to word things a little bit differently. Yeah, I think that's good. I think I'm going to call that good here and end these solutions.